Alright, here we are with the Chevy Cruze, and we're going to show you some suspension stuff on this. We're back with Mr. Bew and Mr. Hamrick again at our Mr. Bew's shop. And this one, like we were going over last week for my class, we have, you know, like front suspension here. We have our lower control arm, control arm bushing. You'll want to look for your wear here, your rubbers to start to deteriorate and fall apart. You have your lower ball joint, and up in the wheel well, where it's going to be a little harder to see, you have your strut assembly and your shock. So the spring way up on top, and then your shock down towards the bottom of it. And moving on to the steering, like we had talked about, have your outer tie rod end here for your steering, and then it goes to the middle, and we'll come here, and here is our steering rack. So this is a rack and pinion system, and you'll notice this one has this big old box right here, but there's no hydraulic lines going to it. Instead, we have some larger electrical wires, because this is electric power steering. So less fluids and stuff to leak and go bad, little less taxing on the motor. So it's going to be electric now instead of hydraulic for this particular car. And then what else do we want to talk about?
Well, there's a good reason they've gone to electric power steering, and that is just what Mr. Hamrick said. You've got a situation here where CAFE standards, the corporate average fuel economy, has dictated that by a certain time the cars have to obtain or attain a certain amount of mileage along with emissions, okay? So what do you do in order to do that? You downsize the size of the motor, and you allow the taxing items such as accessories, such as water pumps, such as power steering, things of this nature, and you get them motivated by electricity, okay? So in these particular cases, we're running a 1.3 liter motor with a turbo that at one time you would have either a 2.0 or a 2.4 liter, and it's running more efficiently, less gas, more power. So there's a lot of reasons why they've gone with electric, and that's because it's a lot easier to create electricity than it is to create power / torque.
All right, moving to the back here, since this is front wheel drive, and we've gone over this a little bit in my class, you have what's known as a dead axle, because we have both rear tires, or rear wheels, connected with what would look like an axle, but it's just a tube in between the two. So you have your springs giving you your comfort in the back. You have your shocks, your control arms, and you'll notice again rubber bushings for the front there, and shock, said that already, and our tube in the middle. That all this does is hold them together and keep them in alignment, and that's pretty much all that's going on back here. Pretty simple.
Okay, along with what Mr. Hamrick said, there's something to be noteworthy here. Here we are dealing in an era where a lot, or the vast majority of vehicles have four-wheel disc brakes, but in some vehicles you will have drum brakes, and this is one of those vehicles. Notice that on the top here you've got the hydraulic line coming to the wheel cylinder on top, okay? And then down below that you've got another wire, if you will. That is the wire that goes back to your wheel speed sensor, okay? And that's actually measuring the revolutions per minute, the RPM that the wheel is turning, and that's how it sends a message to the central processor, of which modifies and pulses and modulates the amount of pressure going to the wheel cylinder.
A little inspection plug for the drum.
Yeah, so now we can, without removing the wheels, find out if we have adequate brake lining. Also, just like we had in the lower control arms, up here, we've got bushings in the front, of which we should be always looking for any cracks, any oil, anything that would deteriorate that rubber is something we need to be looking at. Also, here's another rubber. This is called a coil spring cushion, and they do wear as well. See, back east where you have the salt belts and they use salt on the roads and it snows, you have to really watch for corrosion, and you have to, like I said, rust, brake lines, stuff like that. Exhaust goes bad quickly. But here in California, we deal with smog, and smog actually attacks rubber. So we see more motor mounts, we see bushings going bad in shocks, we see spring perch coil seats, and we're looking through our cars, and when we see things like this is actually a really good example. Notice how we have fluid that's on the outer tie rod. Look, we've got fluid here on the outer CV joint or drive axle. Look, we've got fluid here in the lower ball joint. That doesn't make sense. This has a boot and grease on the inside. This has a boot and grease on the inside. They don't look like they're compromised, nor does this boot look like it's compromised. Look at the bottom of the strut. It's got a moisture pattern as well. So if we keep looking on this vehicle, now we're gonna find out what's going on. Somebody has replaced this caliper and the other side hasn't been replaced. But look down here. We have fluid coming from the caliper. So what's happening is when the wheel is going around, it's creating a wind tunnel in here and it's throwing all that fluid around. So it would be easy to condemn these other parts when in actuality they've done nothing wrong, okay? So we've got a bad caliper. So now we're looking at this car and we've got a relatively new car, but this vehicle actually came in for a overheating issue. So as we start to do our inspection, we find a couple of telltale spots here that are indicative of a hard hit, okay? Now again, this is a turbo car, so we've got an intercooler, we've got a condenser, and we've got a radiator. Strangely enough, the radiator has little to no damage, even though there is some deformity to it, but this car has taken one heck of a wallop, okay? So we should be noting this, and we should understand that this could cause other issues such as this hose leaking right here, okay? In a few minutes, we're gonna be going over MPI, checking out cars, but these are little things that we should be noting at all times as we look at a car, because even though it came in for an overheating issue, we found an MIL illuminated, we found a misfire, we found some things that just don't make sense.
And it drives sketchy. It's terrible. So, all right, let's jump to the 57 for suspension. Okay. While we're still rolling. All right, rolling over here, we have a 57 Chevy pickup, and we want to show you the difference in suspension and a real quick rundown on this. Customer brought this one in on a tow truck as well, and his other vehicles crapped out on him, so this is going to become his daily. But you'll notice this has a solid front axle, something that you're not going to see unless you go back 50 plus years or you're working on a bus or an RV. That's going to be this big old bar right here. And
it's called an I-beam.
Yeah, I-beam or a solid axle. Mm-hmm. And it connects the both the front wheels together. The downside is anything that happens to this side gets transferred into this side because they're connected.
The difference in between conventional suspensions that we see in a little bit later model is instead of having ball joints here like that was shown in the other car, and in most cars with an upper and lower control arm, it has an upper and a lower ball joint. These have what's called a kingpin, of which it has a rod through here, and it literally rotates back and forth on this spot right here, okay?
Little bearing inside there.
Mm-hmm.
Yeah, super strong, but going on 100-year-old technology, and leaf springs in the front here. So again, really old technology, almost back to the covered wagons, little sooner or later, but nothing wrong with it. It functions, but definitely old technology.
Rides like a pogo stick.
Yeah, it does have shocks though, which helps dampen that a little bit, but it's still, really old.
The leaf springs are attached to the chassis by what's called a shackle. In this particular situation, back in the day, they were smart. They put zerks or grease fittings on everything. Unfortunately, because it's been so long since anybody's greased or cared for this truck, most of these zerks would not accept any grease.
Yeah, completely clogged. So moving on to the back, just for suspension on this, solid axle here in the rear, but this is a live axle, not a dead axle like on the Chevy Cruze from a minute ago. So this is going to have your drive shaft coming in, going to your rear diff, and sending power out to both rear wheels. Leaf spring suspension here in the back as well. And this one's a little interesting because it also has these coil springs. We're kind of suspecting that someone might have done a rear end swap on this probably around the 80s when they started kind of getting this truck back on the road. Typically you'll either have just leaves or just coils. And it could be either one, even for pickup trucks. You also have shocks back here, which is nice. Sometimes that was an option for trucks. Now it's all standard, but way back in the day, it used to be an option.
And what we believe the reason is for having the leaf springs and the coils is that when they put an excessive amount of weight, which this...
All right, we're back showing the drum brakes on this 57 Chevy pickup again. Kurt, you want to take over?
Okay, so in my class, if you've had fundamentals or quick service, and for those of you that are in Mr. Hamrick's, there's a statement I want to make, and a lot of times we need to put this together by looking at it, okay? So when we are dealing with vehicles that have brake drums, whether it be all four of which you'll almost never see anymore, or just in the rear of which this is in the front, people need to understand brake pedal height is derived from your adjustment in the shoes. So what does that actually mean? Okay, so we've got a master cylinder that pumps and it displaces fluid down to the wheels, and it pushes this wheel cylinder out from both sides, okay? Hence the reason we have these springs here, and you'll notice these have not been replaced. We always believe in replacing hardware anytime we're performing a friction switch on a vehicle, so a general maintenance brake job, if you will. We were unable to obtain this, so these springs have been reused along with the hold down. So anyway, if you don't have this adjuster properly adjusted, now that spring, those shoes are going to sit a distance away from inside the drum, okay? So here's your drum. And so those shoes won't be touching the inside here and here. So when you go to put your pedal down, these are going to extend and they're not going to have any resistance. So you pump the pedal again, it comes out again, and then you pump it probably a third time, and all of a sudden, wow, I've got a pedal, all right? So think about this. If we have 4 of these wheel cylinders as we do on each wheel, and you're out of adjustment, that pedal would have a really tough time coming up. So now we take and we adjust this out. Notice how the screw is adjusted out. There's the threads, and see how it's adjusted out. So this has been adjusted in order to conform to the inside of that drum, okay? So now when we hit that master cylinder brake pedal, we now meet resistance immediately. Our pedal is high, okay? So when we're dealing with that Cruze, where we talked about that in the last portion of the video, we have rear brake drums. So if you're getting a pedal that's going down, the first place you should be looking, instead of thinking that you need to bleed the system, especially if you haven't opened the hydraulics of the system, is to check your brake adjustment in the rear. First, number one fundamental thing you do before doing anything else.
That's if it has drum brakes.
If it has drum brakes, period. Yeah. Okay.
Go ahead.
Okay, I'd like to add one thing about when you're performing a brake service on drums. It's kind of confusing, but always remember there's a primary and a secondary shoe, okay? What's confusing is the primary shoe in 98% of the time is always the small one. The big one always goes to the rear, no exceptions, okay? So this is primary, this is secondary. So no matter what, remember the small shoe always goes to the front of the vehicle.
All right, a couple more notes on this 57 Chevy along the MPI line. Customer brought this in as it's now going to be his daily driver, and he's definitely on a budget. So we're kind of trying to do the bare minimum for him to get him going. But there's some definite safety things that we have to do. We did the brakes all the way around. This was sitting for quite a while, so we had to replace a couple of these brake lines. They were just completely rusted out. Some of them were okay. So we have them tied in, some of them new, some of them old. To do everything would be a little bit expensive.
Just wanted to add one thing in my class. I showed you in the tools a brake line bender. This is part of what we were doing, just putting new brake lines on it, okay? So that's a situation you would be using it.
Yeah, and we have, actually I have them over here, the flare nut wrench. And you'll notice, I've talked about it, that it goes to where it can go all the way around those lines, compared to a regular wrench that's not going to do that. So for these soft fittings on here, putting a regular wrench on there can sometimes deform these, want to round them over. So you use one of these and you're going to have way less problems with that. Goes same thing with your brake bleeders. This is your brake bleeder. A little less light, Kurt, please. And you go about in the middle. There we go. See, I get in here close, and you put a regular wrench on there, and you're very likely to round that over. So always use a flare nut wrench or a line wrench.
Notice those are new brake hoses and new wheel cylinders.
Mm-hmm. Yeah, these were all rotten and leaking, so we replaced them. And again, like we had stated earlier, this truck was probably messed with in the 80s to kind of get it going down the road. Here's a fuel line that was leaking that had to be replaced, at least a portion of it. And the biggest thing we want to note with this is the tires. This truck never came with tires this big, and we actually have the original size right here on the spare. This is about 6.5, 7 inches wide at the widest point. This right here is about 12. I measured it earlier. At the widest point, it is almost 12 inches wide, just under. This truck was never designed to have tires this wide. If this hits a bump, you'll see that it's going to be extremely close to the side of the bed here and the inner fender. So if you hit too many bumps, you're going to start grinding in there and wearing out your tire. And if you notice in the front here, our tie rod end is actually contacting this tire and chewing into it. This is absolutely terrible. You're just a matter of time for that finishes chewing through there and you have a blowout. And that is definitely not going to be fun.
Huge safety issue.
Yeah, massive safety issue. We let this customer know, hey, as soon as you leave here, you need to go down to the tire shop and have skinnier tires put on, because in 1957, this truck was not designed to have tires this wide.
And in actuality, Mr. Hamrick did recommend tires to the customer, of which he declined, of which he so noted on the invoice.
Yeah, you're absolving yourself of liability because you told them, but you can't force them to do it. Yeah, this is just chewing right into there. Mm-hmm. Another note on putting aftermarket wheels and tires on is, depending on the wheel, you'll notice, let's see, on this side, we have barely any stud coming out to attach these lug nuts to. So when you actually get the lug nut on there, it's only being held on by 4, maybe 5 threads at the best. And the reason is they used a spacer to try and get a little bit of room so that it wouldn't rub. So your drum goes on, then they're putting this spacer on, then they're putting the wheel on, and by the time you get all this stacked on there, you barely have any threads left to grab for the lug nuts to grab onto. So definitely another issue that we let the customer know about, and he said, okay, cool, thank you, and didn't want to do anything.
Hence the reason they put this on here was to try to resolve this, because by putting that spacer on, it brought the tire out slightly. It's not enough.
Yeah, so anytime you start messing with what the engineers and smart people designed into it, you start affecting multiple systems. So you think, I want to do this one little thing, either bigger tires, wider tires, engine mods, whatever. You affect a whole entire system that was designed into the whole overall performance of the vehicle by people that are actually pretty smart, and you almost always affect multiple things.
Mr. Hamrick made an excellent point there. You have a vehicle that has a system, not a part. So if you think you're going to go in and replace a part and enhance performance, ride, suspension, whatever it is you're doing, you are going about it in a corrupt fashion to begin with. It is possible to create something that is better than stock, but you can't look at it as a part. I'm going to add this air intake. I'm going to add these tires. You have to make sure that they work with what's ever there, or make the modifications that are necessary to enhance the system.
Always do the research on it to know what you're getting into, and generally you're going to need to modify a couple of things to get everything to function properly and work together well. All right, here we are with the 78 Kingsley? GMC Kingsley. And what were you saying about this RV?
What is noteworthy about this is, out of all the recreational vehicles or coaches that have ever been made, this one was not the frame of another vehicle. GMC built this vehicle from the ground up. All of the parts that are on this vehicle are indigenous to this vehicle, with the exception of the drivetrain, of which is an old Toronado 455 front wheel drive.
Yeah. So getting to that front wheel drive, we'll notice, take a look under here, and the part of the reason that they made it that way is so the whole entire floor of this RV could be flat on the inside. So all of your drivetrain and everything is up here in the front. What I specifically wanted to show you was the torsion bar suspension on this. So you have your control arm, upper and lower control arm here. Here's your upper, here's your lower. But there's no coil spring there. There's no leaf spring there. Instead, we have this bar that keys in to our lower control arm, and it comes back here, all the way back here to this cross member. And what it does, like I mentioned, is it twists. So as you go up and down the road, there's spring tension on this rod by twisting force. So you dial in a certain amount of tension with this bolt right here that moves on this lever. This is also keyed in the back here, so it can't just spin freely. And that is what supports the weight of the vehicle on the front suspension here, is the tension in this rod, so the twisting force. So unique to this RV, and also on a lot of your Chevy half-ton pickup trucks, your Toyota Tacomas from like the 80s or so, Kurt?
Sure.
So it's still in use, but not quite as common as leaf springs or coil springs.
One of the nice thing about torsion bars is, if they do give up over the years, instead of having to replace the springs, you can actually reclock these springs, putting more torsion on the suspension, therefore lifting it or lowering it by that bolt adjustment.
Yeah. So one other fun fact with this one is, since this is so old, This one has a nice little sewage leak that we get to deal with. Fun side benefit of working on older stuff.
One of the pleasures.
Yeah. All right, so we wanted to show you the type of system this is. It's back on our 57 Chevy again. And one of the pleasures in dealing with some of these anyways, especially on your fronts, is the type of bearing and everything that you got to use. So this would be your inner bearing, and this one's actually ball bearings. And some of them are going to be ball bearings like this, some are going to be roller bearings. Most of your newer ones are going to be roller bearings, and you'll have an outer dust seal, inner dust seal. And this is what comes and rides over here on your spindle. And here's your inner race. This one's actually stuck on there, and that bearing then goes and rides right here, and those little balls sit in the groove right here, and that supports the weight as you're spinning on down the road. So let me grab this and see if I can do this one-handed. Well, Kurt answers the phone, and you want to be careful that your bearing here, you don't lose it when you're doing this. So again, roller bearing, a lot of them are ball bearing. Here's your race, there's your bearing, and then this is your other race right here, and that'll go in there. And let me see if I can get this one-handed. One last note before I pop this on here. This is a riveted shoe, as it's attached with rivets to the brake shoe, and this would be a bonded shoe, so it's kind of like it's glued on there, so you don't have any of the rivets. Different way of doing it. The riveted style can sometimes be a little bit better, but either one will work. So riveted, bonded. So now let me see if I can get this thing on here one-handed without dropping my bearing out. Come over here and find my spindle. Don't drop it. Get it over my shoes. And what just popped out of there was my race. That's okay, I can clean that up real quick. If I drop my bearing, I'd want to get a new one, just in case it had any kind of deformation to it. Alright, pop my race back in there. Okay, that's all sitting in there good. Alright, got the camera a little shaky. Kurt had to answer the phone. Then I'm going to take my washer and castle nut here. So this washer will go keyed in to this groove here, and this castle nut goes on here. So you see it looks like a little castle. And that goes on. And usually you're going to be about 11 to 15 foot-pounds for these to put the proper bearing preload. If you get it too loose, it's going to kind of flop around on you, and too tight, you're going to smoke those bearings in a hurry. So generally 11 to 15 foot-pounds. Get that all torqued on there, and then you put a cotter pin through there and twist it to keep it from coming off. So that's how that all works. Everything's spinning good. Slight drag on our shoes. I'll put the final torque on there, and then we should be good to go.
Notice that when he said a slight drag, it looks like it's kind of a hard drag. Whenever you're adjusting shoes on something that's already been in play, in other words, you've got miles on it and you're going to readjust it, You want your adjustment to be far lighter than that. But when you have new shoes with a drum that's been turned, always better to tighten it like that, because as the vehicle's shoes and drums wear together, which is called arcing, you're going to lose that adjustment quickly. So we save some time in one of the steps by adjusting it with quite a bit of drag on it. There's the spacer that Mr. Hamrick was talking about. Remember, that was to space the tire away from the outer, well, we're going to call it a tie rod.
Yeah, and then this customer has these wheel locks we talked about before. So normal lug nut, super easy to do. Then you got this thing that you then got to use your lock for. So he's wanting to protect his super fancy chrome steel wheels here, because you definitely don't want to have those stolen.
Yep.
I'll get this all buttoned up and get it on down the road.